Hello, and welcome to a short video presentation on how to create an embedded design system with Mi-5 core for Polarfire FPGA. Mi-5 is a microchip soft RISC-V processor. Microchip offers the Mi-5 processor IP and software toolchain free of cost. RISC-V is a standard open instruction set architecture. Polarfire FPGA support the Mi-5 core to run user applications. This tutorial describes how to build a Mi-5 processor subsystem to execute user applications from the fabric RAM. The Libero design tool flow is described here, which includes design entry using SmartDesign, synthesis, place and route, adding timing constraints, design initialization, and programming the device. Now let's move to the microchip Libero SoC tool to create our design. Click on Project. Enter the project name. Set the preferred HDL type as Verilog and click Next. Select the Polarfire FPGA device and click Next. Click Finish to create the project. Create the SmartDesign by right-clicking on it. Enter the name of the SmartDesign and click OK. This opens up an empty SmartDesign canvas where we can create our design. For our convenience, we have already created a simple embedded system design with Mi-5 softcore. Let's go through the major building blocks of this design. CCC stands for Clock Conditioning Circuitry. It includes configuration for the PLL and DLL. We have selected the PLL single option for clocking. The input clock frequency is set to 50 MHz. Core reset allows synchronization of the resets to the user-specified clock domain. This generates reset for all of the cores. This component is the Mi-5 soft processor core. The reset vector address is set to 0 by 8000. This is the address from which the processor will start executing after reset. Core JTAG debug facilitates the connection of RISC-V JTAG debug ports to the JTAG header or GPIO pins. This core facilitates the debugging of the Mi-5 core. PFSRAM provides access to the embedded LSRAM on Polarfire FPGA. It facilitates convenient access to SRAM by AHB Light masters, as used in this design. Memory depth is set to 8192 and data width is 32. The fabric interface type is AHB Light. Once all the cores are configured and connected properly, save the project and generate component. Then build hierarchy. We have added the timing constraints and I/O constraints. Now, let's run through the design flow. Click on Synthesis, Place and Route, and then Generate FPGA Array Data. A green checkmark will appear as each stage is completed. Click on Configure Design Initialization Data and Memories to add hex file. Select LSRAM. Here, we add content from File. Browse the hex file from the Soft Console project. There is separate video recorded for creating the Soft Console project and hex file. When the board is programmed and powered up, the Polarfire system controller initializes the LSRAM with hex file and releases the system reset. The storage type is set as sNVM. Click OK and Apply to save the changes. Generate design initialization data and generate bitstream. After exporting bitstream, we can see our stable file created in a folder. For more information, please visit the Microchip website. Here you can refer to the documents TU0775 Polarfire FPGA and the Libero SoC Design Flow User Guide. Through this document, you can learn how to use the Libero design flow and also how to create a Mi-5 subsystem. Thanks for watching.